Okay, so today we're going to do some practice problems getting you prepared for homework 15 tonight. So we have this f of x function, and we want to perform these transformations onto f of x. And we want to know, what is the new equation going to look like? Well, when it's written in words and you have multiple transformations, you want to do it in the way it's written. Remember, we said earlier that ups and downs are always last and lefts and rights are always first. But when we're actually performing the operation with words, we actually want to write it in and perform it one step at a time as it is written. So we got to do what's in red first. We have to do reflection in the x-axis first. And then we're going to do a vertical translation down 3. And we have to do one at a time. So the first thing you have to get right is you have to know how to write. How do you write a reflection in the x-axis? What's that fancy, what we call function notation? So remember, that would be a negative f of x outside. So the first thing is we have to be able to make a connection between the function notation and the words, right? So that's what I would expect on your homework. And then we have the next one. Then eventually we're going to have to do a vertical translation down 3. So remember, a vertical translation down 3 would mean that would be that notation. So hopefully you can see that okay. I hope that's dark enough that you can see that okay. So we're going to perform each one at a time. So we're going to do the reflection. So that means we're going to multiply negative times the original function. And this is kind of like your homework 9 from a while ago, right? So we have to multiply a negative times the entire function, right? So maybe add some blue into there. And remember, this is your entire function. And then you actually have to do it. So we have to distribute. So remember, it's a negative being, remember there's like a hidden 1 out in front of there, and the negative times that. So a lot of you weren't distributing that negative in your homework. So now that leaves us with negative absolute value x plus 1, and then a negative times a negative 3 is a positive 3. So now we are here. So you are here. So now when we do the vertical transformation, of down 3, we have to do it where we left off. So we have to take the function where we left off, which I'll do in black. So the function where we left off, and then we have to subtract 3 from that function, right? Because we have to go down 3. And then when we actually do that, our final answer, we're going to call our new function. It doesn't get g, h, whatever. We're just kind of emphasizing that we started with this function f, and we wanted to reflect it, right? We wanted to reflect it along the x-axis, and then we also, after that, we wanted to move it down 3. So what would that new equation look like? That's what our answer is. This is just our new equation. And so our final answer would be negative absolute value x plus 1, and then plus 3 and minus 3 is just a 0. So that should be your final answer. Let's try another one. Okay. And number 2, we want to do a vertical translation up 5. And then, right, so we got to do a vertical translation up 5. We got to do that first. And then wherever we end up with, after that, and I'll do this one, I guess, green. And then we'll do a reflection in the y-axis. So first of all, we have to be able to write what those transformations are. So the first one is a transformation up 5. So remember, if I want to do something up or down, I have to put it outside the function, right? So it has to go outside the function. And then after I do that, then I'm going to do a reflection in the y-axis. And remember, a reflection in the y-axis is when the negative is inside the function. That's what it's going to give you, the Queen's wave, right? The Queen's wave is the reflection when the negative is inside. Now let's perform one of those at a time. So again, we do it in the way it was written. So we are just taking the original function, right? Here's our original function, and they want us just to add 5 to that original function. So we're taking our original function, maybe put that in blue, and then we want to add 5 to that function. So that would be 2x squared plus 4 is my original equation. And then they want us to move it up 5, right? We move it up 5. So our final answer would be 2x squared plus 9. So now we are here. You are here. Now we're going to do the second thing, which is to reflect in the y-axis. So that just means we're going to put a negative x where the x used to be. So it's 2, there's where x used to be, squared plus 9. And now we're putting a negative x where the x used to be, and then we have to simplify. So remember, a negative x squared means negative x times negative x, and that would equal positive x squared. So that's our new equation. So that's what you should get for the new equation. Okay, so let's try the next one. So let's look at question 3. So question 3, they've given us 2. So we got to do a vertical stretch by a factor of 2. And then we're going to do a horizontal translation left 5. Right? So let's practice first just writing these in function notation. So remember, a vertical stretch by a factor of 2 means it's 2 times the function, right? Doesn't that match? Doesn't that function notation match those words? And then after that, we're going to do, so I'm going to leave some room. So after that, we're going to do a horizontal translation left 5. So if you want to move something left or right, isn't it inside the function? So to move it to the left, do I put a plus 5 or a minus 5 if I want to move it to the left? So I would put a plus 5 if I want to move it to the left. So see how these match? So the first thing is you have to make sure that you can go from words to function notation and from function notation back to words. So we have to have that down pat, right? We have to be very comfortable with that. So now we're going to perform the first one. Remember, you're multiplying 2 times the entire function. So we have to multiply 2 times this entire function. So it should look like this. You should have, so the entire function is x plus 4 minus 3. We have to multiply that entire function times 2. And then when we actually do the distributive property out in front, you can't distribute within the absolute value. So then that would give us 2 absolute value x plus 4 minus 6. So now we are here. You are here. Right? So did you get that line correct? That was kind of like your homework 9 stuff, and a lot of you were messing up on your homework 9, or you were just copying from me, and so really weren't doing that great. So now we're going to do where we left off. So we're going to do x plus 5. We're going to plug that into where the x used to be. So 2, and then where the x used to be. So all I'm doing is, right, absolute value bars, and then I'm plugging in x plus 5 where the x used to be. So where the x used to be, I'm replacing it with x plus 5. And then we have to simplify what's inside. So what's inside, we've got an x plus 9 inside, and that's your final g of x. That's your final answer. Should have used my paper a little bit, left a little bit more room in there. Okay, number 4. Number 4, we're going to do a vertical translation up 6. Then we're going to do a horizontal shrink by a factor of 1/3. So we first have to make sure that we can write the function notation that matches each of those. So a vertical translation up 6 would be outside the function, right? Adding 6 to outside the function. And then the horizontal shrink, so horizontal shrink means it's inside. And remember, the factor is 1/3, so when it comes back, it has to come back as its reciprocal. So remember that 1/3 has to come back as its reciprocal. I don't know how good you're going to see that green, but right? So you have to make sure that you can first take the words and write it into its function notation. So if that might be something you have to stop and kind of practice some of that first. Now we actually have to perform one at a time. So we have to take the original function. So remember, the original function is x squared minus 4, right? We got to take the original function, and then we have to add 6 to that original function. And then we have to simplify, so that gives us x squared plus 2. So now we are here, and now we have to horizontally shrink it by a factor of 1/3. So now we have to do this to where we left off. So remember, that's going to go in place of where the x used to be. So that's going to take place of where the x used to be. So that's going to be my x is squared plus 2, and then 3x is going to go where the x used to be. And then we have to simplify. So that means 3x times 3x, so that would be 9x squared plus 2. So that's your new function. We're going to just call it g just to say that that was the one after we took the f function and moved it up 6, and then we shrank it by a factor of 1/3. This is what the new equation would be. Okay, let's see if we have time to try one more. So on number 5, we are doing a horizontal translation, right 4, and then we're going to do a shrink by a factor of 1/2. So why don't you pause the video and see if you're writing them correctly. So did you write a horizontal translation right 4? If you're moving it left or right, it should go inside. So the question is, should I put x plus 4, x minus 4 if I want to move it to the right? So if I want to move it to the right, shouldn't I put x minus 4? And that's going to move it to the right 4. And then for the shrink by a factor of 1/2, a vertical shrink, so it's a vertical shrink, doesn't it go outside? Right? Isn't that how you write? So doesn't that match? Doesn't that match what's being said? Let's double check. Is that matched correctly? Horizontal trans 4 units to the right, correct? A vertical shrink means it's outside, and so it's just 1/2, so correct. Now let's actually perform those operations. So this means that we need to replace where there was an x, all of this needs to go where that x used to be. So when we do that, that gives me 3 parentheses, there's where my x used to be, minus 2, end of absolute value, plus 1, and I'm going to put that where the x used to be, right? And now I have to simplify what's inside. So I'm going to erase this for a second because I think I'm running out of room. This is a longer one. So I need to multiply and distribute this. So that's going to give me 3x minus 12 minus 2 inside the absolute value, and maybe even color my absolute value, right, to help my eyes focus. And so inside the absolute value, I now have just a 3x minus 14 inside the absolute value, and then I have a plus 1. So now we are here. Now I have to do a shrink, right? Now I've got to do a shrink, a vertical shrink by a factor of 1/2. So I'm going to do that. I'm going to erase it and do it kind of up in there, right? So I'm going to erase this, give me some room. So doesn't that mean I have to take and multiply where I left off, the whole entire function, by 1/2? So where I left off, so I'm going to recopy what I had 3x minus 14 plus 1, and I have to multiply that entire function by 1/2. That's what this says to do. Remember, it's always where you left off, and so therefore I have to distribute that out in front and distribute that there, so that for my final answer for my g of x, that's going to give me 1/2 times the absolute value of 3x minus 14, put nice and tall, and then 1/2 times 1 is just 1/2. So that would be your answer. One more to go. We want to reflect in the y-axis, and then we're going to do a horizontal shrink of 1/3. So pause the tape and see if you can write those correctly. So did you write that if it's in the y-axis, wouldn't that be a negative x? And for a horizontal shrink, For a horizontal shrink, wouldn't that be f of, and remember, since it's horizontal, this has to come back in as its reciprocal. So this would come back in as 3x, right? Come back in its reciprocal. I guess I should have done a different number as an example. So now we're going to put negative x where that x used to be. So there's where the x used to be, and we're going to put negative x in place of where the x used to be. And then what does negative x squared equal? Well, isn't that a negative x times a negative x? So wouldn't that be positive x squared plus 2? So now you are here. Now we can do the horizontal shrink of 1/3 in green. So that means we're going to replace the x where we left off with 3x. So there's where my x squared plus 2 is. And now I'm going to replace 3x where my x used to be, right? So I'm taking my x out and I'm replacing it with 3x. And then I have to simplify. So 3x times 3x is 9x squared plus 2, and that's my new function. So that's what homework 15 is about. Okay, bye.